you have a jailbreak detection mechanism that when the application is first started, is going to check if the device is jailbroken. You might want to, for example, to monitor these files to see if the application is looking for common paths that indicate actually a jailbreak. In this case, you can see what application is doing and try to actually bypass it. Again, another source that can actually leak sensitive information, especially for financial applications, is the OS pasteboard. We're going to use, again, a background job that actually is going to be run in background and done vulnerable as a test for side channel data leakage, in this case for the passport. Let's say I have a credit card number and a CVV, and I'm copy-pasting it from another application, a note application or KeePass or whatever. And let's see if the application, if the developers forgot to actually disable the feature of the OS that allows us to share this information. If actually, in this case, a malware or on a jailbroken device, someone is actually be able to retrieve this sensitive information. So we are, in this case, I'm just running one background jobs every time, but nothing actually prevents you to run a multitude of background jobs at the same time. When kill the jobs, we see that actually the developer forgot to disable this feature, so we can actually retrieve this information. Then another source of data leakage, usually is very common, is the syslog. So you might want to watch in real time or monitor in background the syslog. We're going to check also, again, with another check, we're going to try to log something on the syslog. When I'm going to tap the button at the bottom, done vulnerable is going to actually log something on the syslog. What you're going to see if you can actually intercept, if you can actually record this syslog. Again, just to remember you, the output is also going to be stored locally on your file system, just to actually be quickly and easily grabbable. So in this case, it was actually everything that actually I wrote was logged to syslog. And then in the newest release of Needle, not in this one I recorded, you can actually apply filters to just record the syslog that has been printed by your target application and to filter out all the operating system logs. Another category, very, very important, is actually hooking. When you want to manipulate the runtime of an application to try and manipulate its behavior. Now, Done Vulnerable has a feature that simulates a passcode. For example, when you use a banking application, you might have to enter a PIN code to use the application. This is a similar feature. So we want to actually bypass this feature. So from the class dump we did before, we reviewed this class dump, and we saw that there is a controller, runtime manipulator controller, that contains a method, validate code, that returns a Boolean and accepts an integer. So that might be actually a good starting point. Now, for hooking, Needle is highly integrated with the two major hooking frameworks, Script and Frida. We didn't want to reinvent the wheel. Script and Frida are actually awesome. They are just a bit problematic in the setup and in the configuration. That's the part that we are actually automating with Needle. So we'll see later with Frida. For Script, for example, we have the chance to just end up in a script shell. So Needle is going to start the application for you, retrieve the PID, and spawn a script shell with this attached to this running process. And from that, you can start actually using script like you always do. So in this case, I'm going to check if this application, if this method is actually what I'm thinking it's doing. So I'm going to try and enter a random number and see what's the application returning. It's returning a 0, which means false. So maybe actually this one is the method I'm looking for. So what I want to do now is to try and brute force all the PIN code. I don't know which one is the PIN code is correct. So I'm just to create a for loop and iterate through a number of integers and try to invoke that function for every integer. And I'm going to record the result. At the end, I'm going to see if there is at least one integer that is going to return true. In the meantime, while I type this loop, A similar approach is also used by Frida. Frida is actually very awesome, but can be very tricky to set up and to install. Also because every time you have to remember to start the server on the device, you have to remember to set up a local or remote port forwarding, depending if you're using USB or Wi-Fi. And then you have any way to use a script to inject, a Python script to load and inject your payload to the running application. So takes time every time. It's very error prone because you have to remember IP addresses and everything. So what we are doing also with Needle, we see that after this example, is to completely integrate that. So you can actually just focus on the JavaScript payload that needs to be parsed by Frida and forget about the rest. So what I'm doing now, for example, again with the for loop, I'm just going to almost complete. Now I shortened the video quite a bit just for this demo. At the end, I'm going to print the content of the result. I'm going actually to check if this pin is the correct one used by the application or not. So it's 181. Quickly check if it's the correct one. Which is correct. So quickly, with 5 lines of JavaScript and script, we were able to bypass this feature. So let's now focus on something that is very common during assessment, jailbreak detection bypass. That's because you want to run the application on a jailbroken device. Again, from class dump, we found a class related to jailbreak with a method which returns a Boolean. So you can see here is approach similar to the previous example. But again, there is a check, for example, when I tap on jailbreak test 1, you see that the application found out that the device is jailbroken. Now I want to modify this behavior. So one of the modules integrated with Frida is a Frida launcher. In this case, you only have to specify the path of the JavaScript payload you want to actually have Frida to parse and inject into the runtime of the application. So in this case, I already prepared a simple JavaScript to bypass the jailbreak detection. Is a few lines, 5 lines of code. I'm going to hook the jailbreak detection class, and in particular the isJailbroken method with the correct signature, and I'm going to replace the implementation. So quickly, what I want to do is just change the implementation and make this method return false every single time. So the application will still perform its check, but at the end, I'm going to inject this code that will make this method return false every single time. So in this case, Needle is going to take charge of spawning the application, set up port forwarding, loading the JavaScript, do whatever. So we are running the application with this injected JavaScript, and if we now try the same test, you see that the application believes the device is not jailbroken anymore. Again, very quickly, very easily using Frida and Needle. Another thing that Frida is very useful for is a tracing method. If you're just starting to analyze an application, you're not sure what methods what are being called by the application, so you might want to start tracing this application. You can trace function, methods, or modules. So at the beginning, I'm going to just trace functions like send and receive that are connected to network communication. So I'm going to start using the application. In the meantime, I see network communication flowing. That's not really useful, though. What I want to do is to find another way to bypass the jailbreak detection test using this tracing feature. So I can just quickly unset the previous filter and then try to trace the same method I had modified like in the previous example a couple of seconds ago. So you can just specify what method to trace. Remember the correct signature, also if it's an instance of a class method. And then when you're done, automatically Frida is going to create some handlers for you. You can actually run the application. And we're going to see when we tap the jailbreak test button, we will see recorded also that code. So we see actually that button is related to that function. So we see that actually when we tap on that button, we're going to call that function. So Frida is useful also because it's going to auto-generate some handlers for you. When you're starting to trace method, this is a feature not well documented, it's going to actually automatically create some stubs for you. If you're going to see at these stubs is for the method you are trying to trace, you have a couple of features on enter and on leave. You can quickly modify. So if you modify the onEnter function, is actually code that is going to be executed when you enter the trace method. If you modify the onLeave, contrary is when you're going to leave that method. So what I want to do now is to insert in the onLeave function a new return value. So I'm also adding a couple lines of logging just to be clean and neat. So I'm just logging the original value calculated by the application. I'm going to replace this value with false because I want to bypass the check. And then I'm going to print the modified value, just to be very clear in my output. So like we saw 3 lines of code, 2 are actually logging, so just 1 is the actual bypass you had to. So let me restart the tracing with this modified handler. Now, when I'm going to check, actually, you see that my handler is going to be actually parsed by the application, so you actually are able to bypass this. And then we have also another series of modules integrated with Frida. We have Frida shell that ends up you in a Frida shell if you just starting the test and you are still not sure what you're looking for, so you just want to play with an interactive shell. But then we have a series of modules that are going to be added modules in the futures already integrated with Frida. For example, we have a couple of modules that can help you dump classes. Here you just need to specify, we have a JavaScript that is going to be injected, and you just have to specify the JavaScript the same way. So in this case, we saw that class dump is starting to fail on iOS 9 and 10 and on 64-bit devices. So one way to bypass this, since class dump is not very useful anymore, is to actually use Frida to dump all the class and method interfaces in the same way class dump we're doing. So I have a new way to do it. And we already have some modules to automatically dump everything, or just to filter out, select a target class, and just filter out the method of that class. Then, another section, we reviewed the runtime of the application. We started manipulating the application. Then we usually want to actually test also the transport communications. So something that wasn't very easy to automate was the management of the certificates installed on the device. Now here we have modules to list all the CAs installed on a device, or you have with all the subject and all the details. You can also decide to export these certificates if you have to clone a device and you want to install the same certificates over and over again. You can decide if you just dump the public key or also the metadata associated to it. And at the end, you will have everything in your local workstation. And then you have other modules that allows you to, in this case, just printing the content of the dump certificates. You have the public key of the certificate dumped from the device. And then you have other modules that allows you to delete CA installed on the device automatically, to import them, to anyway manage all the certificates. So we can do that. So what we want to do is to intercept communications. Before being able to do that, to intercept also HTTPS communication, to break the encryption, we have to install the CA of our intercepting proxy on the device. So that means that you just have to connect the device and the workstation to the same Wi-Fi, and to configure the device to use the workstation running Needle as a proxy. Now, the usual process is I forgot my IP address, so I have to type ifconfig to remember it, and then I have to go and set up. So in this case, until I have to remember it, automatically Needle will just tell you, configure this device and set up the device using that IP and that port. So you can just go quickly and set it up. And when you're ready, Needle is going to automatically start the installation process of the CA for you. Only thing you have to do, and if you use a passcode in your device, then it's just to type your passcode. So in this case, I'm setting up my server and the port of my workstation running Needle. When I'm ready, it's going to just start the installation process of the CA. In this case, I didn't have a passcode on my device, so it's just a matter of tapping install, install, install. So okay, we installed also the CA of our intercepting proxy. Now it's time to intercept the communications. What we can do is to decide if we have a scope, we can specify what we connected to the same Wi-Fi. We have the CA. If we have a scope, we can just list in the target domain if you want just to intercept the domain which are in scope. But then everyone wants to still use burp during assessment because burp is a standard de facto. So you can also set up an upstream proxy if you want to also forward all the traffic intercepted by Needle also to burp, for example. Now I'm using the application, I already see traffic flowing. Let me check if I actually can get also the content of the request. Here, there is another feature that actually where Dan Vulnerable is going to set fake requests to Google. Let's see if actually was able to intercept them. We see that in the output you have also all the content of the request in the same way, on the same way that you actually might have also on burp. And then you can actually still use the upstream proxy burp to keep going on with your analysis, with repeater, intruder, and everything. But still you also have a log of everything you did, everything you browsed. Finally, the last topic is the one related to network, to static analysis. We saw that code reviews are an important part of the analysis. So you can just specify the folder containing the source code, or if you have two different versions of the same code base, let's say release 21 and release 22, you want to see if the new release introduced new issues, Needle can automatically calculate the diff of these two versions and just apply the check to the modified files. So we have a knowledge base that we keep maintained updated for insecure features and functions that might introduce issues. And at the end, you will have grouped by category, by handler, web views, SSL, logging, a list of file names, line numbers, and the offending line. Now, if you are dealing with massive code base, this can actually speed up the testing because you don't have to actually go through manually every single class in your source code. They just use this as a pre-filter, since it's going to filter out everything that's not security related. So roadmap. First of all, we are starting already to create an agent to deploy on device because we want to get rid of all the dependencies apart from script, Frida, and burp suite. So we want to get rid of class dump, we want to get rid of OTool and all the others, because with many different versions of iOS now, iOS 9 and 10 is going to be released in a while, the jailbreak, we are starting to see that these tools starting to show their limitations. So we want to get rid of them and have one single agent created by us that can actually be used to perform the same task. And also this agent might allow us to provide support for testing on non-jailbroken devices, but that's topic for another time. And see, we also want to add loads of new modules, substrate integration with the Cydia substrate, WebView scanners, automatic detection and bypass of pinning and obfuscation. So there is a huge list of new modules we want to add. Remember, the Needle has been released a Black Hat just 1.5 months ago. All of this is community-based. Needle is open source on GitHub. Everyone is encouraged to contribute. Since its release, we already have a few users that started building modules, adding modules for Needle. So if you want to help, the source code is there. Just give us a shout. Everyone is welcome. So if you want to know more, also the first is the link to the GitHub profile, and the second one is the Twitter handle for Needle. And thank you very much. If you have questions, I'm going to stick around anyway. So thank you very much. Sure. Sorry? No, just for iOS, not for Android. No, you can have an IPA, which is a binary. You can have an IPA. You can install the IPA on the device, and then you can actually start analyzing it. And then if you have source code, you can actually run the modules related to the source code. But if you don't have source code, it's the same. You just need an IPA, though. Sorry? Okay. No. Well, if you have just a source code, you can just run all this check against the source code, and you will see if actually there are insecure features or functions. But then, if you actually to properly test the application, you will need a build that actually is being built.
So hey, Mehmet here. Anyways, I saw a couple of languages in there. So we saw JavaScript being injected through Frida, I guess. Is that because Frida relies on JavaScript?
Yeah, exactly.
Okay, and then, I don't know, some script in there that also kind of looked like Objective-C is...
Okay, no, the entire needle is built in Python, so everything is running on Python. We have JavaScript because Frida and script are using JavaScript payloads. Objective-C probably was the last one when I was analyzing the source code, but we don't use Objective-C. We don't code Objective-C for needle.
Okay, with these tools, there's no actual Objective-C direct
Exactly.
injection. But I noticed on the list at the end, you said something about Swift.
Swift, that's why in the future we want to try and add a way to actually hook also Swift methods. Because at the moment it's not yet supported by anyone. That's why one of the things in our to-do list we want to start adding.
So when I write a module with Python now, what comes out of the box? Is there, I mean, because I noticed you said that when you're doing all this stuff with all the modules, right, it dumps things out into a file for you. For example, strings.txt.
Yeah.
So if I'm writing a module,
Yeah.
right, is that a convention that I follow, or is that...
Okay, for example, there is a contribution guide that is going to explain you. For example, there is a function that's going to say save output. You can just call this function, and it's going to save it on your local workstation in the local folder you are using for the test.
Awesome. Okay, and then the last question I have for you is, maybe I'll come back to it. I'm losing my...
Okay, sure. No worries.